Hello, everyone, and welcome to this week's Stellar Developer Meeting. Today, we have the team from Blend joining us for a code walkthrough in support of their exciting new security initiative for the Stellar ecosystem. I'm Carsten, as usual, from the SDF DevRel team, and Alex will join us from Script3, and Amen from Certora. To set the stage here, Blend is getting ready to launch their Blend V2. And in preparation for that, they're opening up their code and for a groundbreaking $125,000 in USDC competition focused on securing Blend V2 through both a competitive auditing and a formal verification. This is the first ever open competition, competitive audit and formal verification competition within the Stellar ecosystem. So it's an amazing opportunity for Stellar devs to try their hand on competing to find bugs and write formal verification rules, or just get more familiar with Blend in general. So I'll post a link to how to sign up for the competition. The competition started this Monday, so it is open. But let me now introduce Alex.
Hello, thanks for having me.
Welcome, Alex.
Do you just let me know when I am
Yeah,
ready to get running?
go ahead. You
All
are
right, perfect.
sharing your screen.
All right, thank you. So yeah, I am Alex. You might see me online as Moots12, and I'm the lead developer at Script3, and we developed Blend, which is a universal liquidity protocol primitive. Just for a quick overview, what we're going to run through, we might go a wee bit fast because there's a lot of stuff to cover. But I'll give you guys a quick, for those who aren't familiar, just a quick breakdown of what Blend is, how the actual contracts all work together. And then I'll run into the code, and kind of the main thing I'll try and focus on for those doing the audit competition is really going to be how we test Blend, and specifically if there is some kind of bug or thing you found within Blend v2, kind of some tips and tricks on how it might be a bit easier to prove that something is in fact wrong. So yeah, Blend is a universal liquidity protocol primitive. And what does that mean? Basically, Blend is a tool that allows companies, people who are crypto natives, really any entity that wants a lending market to actually go ahead and have one. So lending markets in the world of crypto are just places where people can lend and borrow assets from each other. And one thing that Blend does is Blend basically comes with an automatic backstop module, which acts as insurance, bad debt protection, and also scam protection. And these are funded by anyone. And kind of the way this all works together is the pool will give some portion of the interest it generates out to the backstop module, such that it can provide that layer of insurance for the protocol. That was just a really brief intro as to what Blend does. I want to touch on first actually how the contracts all work together, since when looking at this from a securities perspective, knowing how the main components of Blend interact is pretty vital. So kind of the really cornerstone part of Blend is the emitter contract. This doesn't have very many responsibilities. Its core one is going to roughly define the admin protocol token, in this case is Blend. Secondly, it's responsible for defining the backstop module. Now, the backstop module is, like I said earlier, the contract that basically holds all of the insurance funds for the Blend pools. Insurance funds in this case are going to be Blend USDC LP tokens. So there is a common AMM. It's for those familiar with EVM, it's basically balancer, but it's just an LP token for Blend USDC. Its main responsibility is it actually controls the state of the pool. So if you have a lending market and there's a backstop module, the backstop module actually has the ability to turn the pool on and off. So for example, if something happens to a pool or it gets exploited, some oracle goes wrong, the backstop module actually has the ability to disable borrowing for the pool. Secondly, it's also the first loss capital in the event of any bad debt. And those that might not know, bad debt is basically the case where a user has liabilities and they have no collateral to cover it, so the protocol has to take a loss on that debt. Secondly, it also manages the Blend emissions. So the protocol, basically starting from the emitter, Blend tokens will get sent to the backstop module, and it's the backstop module's responsibility to send it to all of the pools within the Blend ecosystem. Within the backstop module, it also defines a pool factory. This thing's job's pretty simple. It's a contract that contains a pool WASM, and for any pool that's created, this is the thing that validates that this is in fact a blend pool, and it is the exact contract that we expect to be deployed. And then the meat and potatoes of the protocol is going to be the actual pool. This is kind of the sort of Aave part of the whole protocol. It is the place where people can go and lend and borrow reserves. So there's tons of different ways you can set things up, but this is kind of the place where all the lending and borrowing occurs, and kind of where most user interaction will end up taking place. So I know that was really fast, but hopefully, this is being recorded, right, Karsten? I think it is. I'll take that as a yes.
Yeah, it's recorded.
Perfect. So yeah, we can probably go back and watch that over if anything was missed, and I'm also available in Discord if you want to ask further questions. But we will jump to the actual codes, since that's probably what a lot of you all are interested in. So I'll give a quick breakdown of how contracts actually exist in Soroban, and then we can start trying to dig through some of how our code's actually tested. So for those that aren't familiar, the way we have set up our Soroban repository is you'll notice that all of the core contracts that I talked about earlier are located within their own folder. So for example, all the code for the backstops within the backstop folder, pool within the pool factory, etc. Each contract has a contract.rs file. This is really the entry point and interaction point for the contract. So you'll notice that in Soroban there are these macros: contract client. These are really the things that define how users actually can call into the contract. So anything that's public facing is part of this trait, and will be implemented for the backstop contract struct. This is also the location where we probably have all of the most user-facing documentation for each of the functions. So if you're ever curious about what's available on a contract, what the arguments mean, this file will be the place where they're documented. So yeah, and there's also a contract implementation macro. So this will be the place where a constructor is defined. So this is basically called when the contract's first deployed and can never be invoked again. And there's also the backstop trait implementation for the contract, and this is where all of our code is basically getting defined. So everything in here is exposed for anyone on the blockchain to interact with. The way we structured things is we generally do all of the authentication that's required to use the contract here, and then we actually perform all of the logic in a second helper function so that we can better unit test the code as a whole. So you'll notice if you're ever looking for authentication things, you'll notice that all of the auth actually takes place here. If you are from the EVM world, how Soroban does auth is probably one of the largest differences between the two blockchains. So it is worth looking into. It's incredibly well documented on Soroban's documentation. So I would highly recommend reading through how that works. So you'll also notice that, for example, if I go to where we actually define the logic, this is pretty common throughout all of our contracts. So we'll basically try and wrap all of the logic that's external to authentication and stuff within a function, and we actually go through and write unit tests specifically for those functions. So this is a pretty good place to look if you think something might be incorrect or wrong, or a bug exists somewhere. This is probably one of the easiest places to start testing that and attempting to find whether or not something's wrong. And you'll often find that this is like kind of where most of our unit tests actually occur. Secondly, one thing that we do include within this blend contracts repository is there's mock contracts, and there's also a test suites folder. So one thing that's really nice about interacting with Soroban is, as I'm using tests, you'll notice I have Rust Analyzer installed on my VS Code, but you have the ability to step through debug. So if you're ever curious about what actual values are within a function, you can use all of the Rust internal tools to step through and actually debug it. If you're like most developers in the world, you're just going to add a whole bunch of print lines and then run the test. That also works fantastic too. But it's really nice. For example, if you do think something's wrong, make sure to use the Rust tools and use all the debugging tools to your advantage. We've been able to find a lot of things internally using those strategies. But one really important thing I wanted to touch on, especially for Blend contracts, is we have this giant test suites folder. We use a lot of this for all of the integration testing. So for example, there is a test fixture. This basically just contains a whole, it's basically going to deploy from a fresh environment a whole bunch of contracts and things that exist to basically support a pretty standard Blend pool. So you'll notice it's going to make tokens. It adds a whole bunch of users. It deploys all of the contracts out for you. And you can basically then start from a really good starting point to actually write an integration level test. One quick thing to note here is that if you ever see in our test the user Bombadil, I'm a bit of a Lord of the Rings nerd, so he is the admin and ruler of everything, so he has the power to basically mint tokens at will. He's kind of the admin super key for roughly all of our tests as well. But how this is actually implemented, you'll actually notice if you look back at some of our older audits, we've written integration tests after basically fixing issues that have been found. One of these was an inflation attack that I believe Certora found in the first audit. But for example, this kind of walks you through a really good way if you think something does exist that might have an issue. Writing one of these level tests is a really, really good way to actually prove whether or not it exists, since this kind of is what at this level of test, this really is the place where you're going to have the same level of interaction that someone using the blockchain would. Then yeah, maybe the last thing to note before I switch over to the fee vault here is you'll notice on the test fixture, when you create the test fixture, there's a true false. Just so it's clear, you have the ability when running Rust integration tests to actually deploy the contracts and use WASMs. So if you want to use the actual WASM files that are being deployed, that's great. We do that in plenty of tests, but if you do that, Rust itself won't actually be able to debug the code within the WASM packages. So if you're expecting some of the print lines or line by line debugging to work, you will need to deploy all of the contracts as Rust crates. That way you can use all of the unit testing tools. So yeah, that's probably all I'm going to touch on here. Again, within test suites and test, this is tons of really good examples on setting up all different kinds of environments if you want to go through and attempt to prove that something is incorrect. Lastly, I'm going to also run through the fee vault contract. This is basically a add-on contract that's aimed at wallets that will allow users to specify either a fixed rate of return or a capped rate of return. So for example, if a wallet wanted to offer, say 10% on USDC deposits using Blend, they can deploy one of these fee vaults. If the Blend pool is returning more than 10%, they would keep that extra, say it's returning 15%, they would keep 5%, 10% would go to the users. Or they can just take a fixed interest take off of all of the interest generated for deposits through this fee vault. So it works pretty similarly to any ERC 4626 function or 4626 vault token. So those that are familiar or have looked at those kinds of protocols in the past, this should feel somewhat familiar to you. I did want to call out one thing. You'll also notice some of the implementation patterns we use in Blend also come over here. So the only thing that's maybe a bit different is this contract's a bit simpler. So you'll notice we've there's probably one less layer of abstraction there for you to have to deal with. Most things are documented pretty well in code, but if you find anything, please feel free to call it out. You'll notice that in the test here, it's set up a bit differently. So for example, This is a very long test, but we mainly are testing the fee vault through integration testing, since the contract is a bit simpler, and it relies heavily on the blend contracts themselves. So you'll notice that we support a blend Rust crate that includes all of the blend contracts themselves. This has been updated for the exact hash that was pushed for the audit competition. So you'll notice that I believe, yeah, the version is here. But this comes with a very similar deployment script as the one we use within the blend contracts repository for their integration test. So let's see if, yeah, there's a blend fixture deploy function that will actually go ahead and create all of the blend contracts needed to interact with a very similar setup as to what blend v1 mainnet is. So if you do run into anything with the fee vault, this is kind of a great place to look to go ahead and try and prove that something in fact is missing or has a bug. So yeah, that's probably all I wanted to touch on. I wanted to make sure I left a little bit of time for Certora to go through the formal verification portion of the audit competition. But I'll probably leave it there unless there's anything else you want me to touch on, Carson.
Great. Let's wait and see if there's any questions at the end. But thank you for the presentation. I'm going to invite Certora and Armin on the stage. Welcome, both of you.
Hi. Armin, are you there? Okay.
Yep, hello. Well, you have my screen. So this is the contest repo. So Chandra, you can let me know what we should walk over.
Sure. Yeah, you can share and I'll just go over it. So as Alex mentioned in his presentation before, we are doing this audit and formal verification contest for Blend. And while the audit itself, you can, all of the code base is in scope. For the verification part, we have a smaller scope because the protocol is, there's a lot of code. And so we decided that it would be more tractable and manageable if we try to focus on one particular part. And in particular, we are looking at the backstop crate. So if you go up a little bit in this repository, so for what it's worth, this is the repository where all the code is. So you can clone this repository and then you can check out all the different crates. And in particular, the one that we are talking about is the backstop. As you can see, Armin has it here. And I want to show the Certora specific stuff. So first of all, the properties that you're going to be writing are going to be in the Certora specs directory where Armin is right now. I think I have a couple of little, now can you go maybe look at some of the other files? There's a few that I provided just for an example. Yeah, so here's a few examples of things that you, just to give you an idea for what these look like. So you can notice here that there is this thing called CVLR_assert in all the rules. And so the things that are, so that's one thing I want to talk about a little bit. So if you look at line number 5, this is the, we call it Cavalier. So Cavalier is the specification language that we've built. It's just a Rust library, so you can import the library and then you can use the various assertions and which are just macros that we've defined. So assume, assert, and satisfy, I think, are probably the most common ones, and the ones that are, I think, we recommend using the most. If you need something more specific, then you can always reach out and we can help you figure out how to do that. The other thing worth noting here is, can you, Armin, can you go down to the cargo toml file at the bottom? Yes. So we are also relying on Rust features. So for example, here you can see on line 17, there's this feature called Certora. And the nice thing about this, this mechanism is it actually lets you use this feature to selectively compile the code. So for example, you can, if you go back, Armin, to, let's see, let's go in the backstop. Yeah. and maybe in the withdrawal. Maybe go to deposit, actually. Okay, perfect. So if you look at the top of this file, you will see that we are using this feature called Certora. And essentially what this is saying is that when the feature is enabled, and I just showed you before that in the cargo toml, it is enabled, then use this mock implementation of the token client, and otherwise you can use the whatever default one that Blend was using. And this is just for verification only, right? So when you're compiling your code for other purposes, then you shouldn't be using this. But when you're doing verification, this is helpful because a lot of the times we want to modularize things. And so you may not need to include all the code for the token when you're really just verifying the code for the backstop, right? So that's an interesting feature that I think you'll probably use quite a bit. And always feel free to reach out on Discord if you have any questions. The other thing I also want to highlight is the conf files. So on the left, you will see that there is this directory called confs. And here we have provided some setup and some skeleton for some basic confs. So let's look at the one. Yeah, the withdraw one is a good one. So what's happening here is we have this file that has a build script. This is already provided. You probably should not have to modify this at all. It's just a Python script that does a bunch of stuff that is necessary for making sure that the reports look nice. You have all the files uploaded there. It calls the right build instruction. In this case, we're using this file called build system called just. But other than that, you should not have to modify that, more or less. Then there's a few verification specific things. So for example, there's this thing called, we have this flag called optimistic loop. We don't need to worry about what that is. I would leave that there. There's also this precise bitwise ops flag, which is set to true. What this is saying is that when you're doing the verification, use bit vectors. You may or may not want it. You can, if you're facing like slow running times, I recommend taking it out and seeing what happens. And again, if you run into any issues when you take it out, you can reach out and we'll try to help you. And then really the main thing you will have to modify is this rules field. So whatever rules you write, you just have to add them to this file, and then you just run this Certora Soroban prover with this configuration file. One thing I would recommend, so it is very common for users to run the prover with many rules, and that is what you will do in the end. But when you're debugging and when you're just trying to test things out, it is often helpful to just run one rule at a time, so you know which rule is problematic, or which has a vacuity problem, or all kinds of stuff, right? So definitely keep that in mind when you're just getting started and writing these rules. As I can tell you, there's a lot of excitement already on Discord. Lots of people have been asking lots of questions, really good questions. So it's already really nice to see the engagement from the community. So that's really cool. So I think, let me just think what else I would like to show. Actually, yes, can you, Armin, if you click on the documentation page that you have open. So here we have some documentation for using Sunbeam. So there's the installation guide, which I think you probably don't need to worry too much about. If you have installed Certora CLI, you should be good to go. So I don't think you need anything else. So the user guide is the main thing. We have some examples of what the different components are. So for example, here you see this like hash rule thing on top of these functions. So really what's happening here is you're just writing Rust functions, right? So Certora is interpreting those functions separately, especially for verification. But from your point of view, you're just writing Rust functions with special macros and special annotations. So that's one of the annotations is this rule attribute. And I already mentioned the CVL assume assert macros from the Cavalier spec library. Another thing that is very useful is this notion of non-determinism. So oftentimes what happens is when you're doing verification, you might want to sort of summarize some piece of code because maybe that's not super relevant for the property you're verifying, and all you care about is that that function returns some non-deterministic value, right? It could be a U64, it could be I128, whatever. It could be a user-defined type, all kinds of stuff. So this non-det gives you a mechanism to do that. So Cavalier actually already implements a bunch of non-dets for various primitive types. Blend has a lot of user-defined structs, right? So for example, there's the Q4 withdrawal struct. You might want to implement the non-net trait for this struct, right? So you can do it this way. So right, like there's an example here. So essentially, all you do is you assign non-det to all the fields of the struct, and you're good to go. So this is something that's really helpful for verification. We often have to do it, and I'm imagining other people will have to do this as well. We have some very basic examples in the tutorial. So we have a Sunbeam tutorial over here. It gives an example of the token contract. So if you've never done verification, I think this is a good way to start. You can just do the exercises here, and just try to understand like what's really happening when you run the tool and so on. And other than that, if you go back, I think I already explained the scripts, the build script stuff. If you scroll down a little bit more, Armin. Yeah, I think these are already covered. All this. So I think the main other thing I would recommend looking at is what happens when you do run Sunbeam. So as I mentioned before, and it's actually also listed in the README for the repo, all you do is you just run Certora Soroban prover, and you pass this conf file. And you run it, and all you get is a link to a run, right? And this link is going to look something like this, right? So here you can see, so here there is no violation, so you're fine. But if there is a violation, you can see a call trace. The call trace is not super easy to read. So if you are stuck with problems with the call trace, please post messages on Discord, and we'll try to help you as much as possible. You can also see the code, right? So for example, here on the left, you have these files. You can see all the files that you used to run verification, all the properties that you ran, all the code that you changed or all properties you wrote, everything is here. And I would always encourage you to, if you are having any problems, you can just send me a link to a run, and then I can take a look at the run. I can reproduce the run locally and help you debug your problems. Other than that, I'm not thinking what else would be useful. I think that might be all I have. Like, oh, actually, I would like to mention one other thing. So we already saw the Certora feature mechanism where you can selectively decide what functions to include when you're compiling. We also saw the non-det macro. Another thing that you may have to do is summarize various functions. So this is something that, for example, here, the best way to do this is the following, right? So in the Certora specs directory, there is a directory called summaries, and in there you can, so the mod is just that's where you just expose all the summaries that you have written. So here there's this file called emissions. And in emissions, it's possible that depending on the property you're proving, you might have to summarize, right? So for example, you can say that I don't really care what emissions does as long as it's returning a non-deterministic value. Or you can say that, well, it should be a non-deterministic value, but maybe it should be in some range. So this kind of stuff, right? Like, it really depends on your understanding of protocol and like what you think is necessary for whoever is calling this function to know about this function's behavior, right? So this is actually often very helpful. So you can put all your summaries here, and then wherever you're calling the function, instead of calling the original function, you just call this function. And it would be really good if you actually annotate it with this feature, because then you're not really changing the semantics of the original program.
Great. I think we need to wrap it up here, but
Okay.
Thank you so much for this presentation. I think this was very helpful for everyone who's going to participate in the competition to get the walkthrough both of the code and the verification here. So thank you all for joining. I didn't see any questions in the chat, but yeah, feel free to reach out. Also in Discord, if there's anything, I'll post the link again in Discord for the competition. So good luck to everyone. The competition is running until March 17th, so still have plenty of time to dig into it. Thank you everyone for joining. Thank you, Aman, Chandra, and Alex for joining here for us. Thank you everyone.
Thanks, everybody.
Bye.